Hello people, today we are going to start with a new series, limits tutorial. So the goal of this video is to understand what is limits used in calculus. So let's get started. One of the basic concept to the study of calculus is the concept of limit. This concept will help to describe the behavior of fx when x is approaching to a particular value, let's say c. In this section, we will review and learn more about function graphs and limits. So let's see first example. There is an equation which says fx is equal to 2x minus 1. Function fx is equal to 2x minus 1. So we have to discuss the behavior of fx when x is close to 2 using this graph. So in this graph, we have using different values of x, we have calculated the value of fx and plotted this graph which is fx is equal to 2x minus 1. So this line represents 2x minus 1. So when x is closer to 2, what happens? Where is x equal to 2? This is 2. When x is equal to 2, what is the value of fx is closer to 3? How? When you put 2 in this function, 2 to the 4 minus 1 is 3. So when x is 2, this function is closer to 3, because y on the y-axis this is 2 and this is 3, this is 4. So this is y is closer to 3. Therefore, the limit fx as x approaches 2 is 3. So that's how we calculate. So when we write the limit notation, approaching is with the arrow, x approaches to 2, the limit of 2x minus 1 will be 3. That means f of 2 means replacing x with the value 2, then putting the value of 2 to the 4 minus 1 will give you 3. So as x approaches 2, the y value or fx function fx value goes to 3. So you can put the value and calculate, or you can use the graph by seeing what is the value of y-axis as the x-axis approaches 2. So as this approaches 2, on the graph the line approaches y on the line approaches 3 on the y-axis. Discuss the behavior of the values of fx when x is close to 2 using table. So using table also you can calculate by taking values which is closer to 2. So 2 is in the middle, we took value 2.001, 2.01, 2.1, 2.5, and on the other side of 2 less than 2 is 1.999, 1.99, 1.9, 1.5. So when you put these values on the function fx by replacing x and putting the x value, you get the y value, that is function fx value, which is fx. If you put and calculate, you will get these values. So for we see that as x approaches to 2, fx approaches to 3. So as you see that whenever we are putting values, we are seeing that as x is approaching to 2, 1.99 and then 2, the fx value is approaching to 3, almost 3. So here it is 2.998, which is almost 3 but not 3. And when you increase the value from 2.001, it goes away from 3.002. So it moves further away on this side and this moves closer to 3. So we see from this table that as x approaches to 2, fx approaches to 3. So this is the notation we write, limit of 2x minus 1, or limit of the function when x approaches to 2. This arrow signifies approaches. X approaches to 2, we get the value 3. So f2 is also equal to 3. Find the limit as x approaches to 2, x approaches to 0, x plus 2, and limit at 3x plus 1. So what should we do? First we should put the value 0 in place of x. So when you put 0, the x plus 2, that means 0 plus 2, you will get 2. So the limit of x plus 2 as x approaches to 2 is 2. Then again, let's put minus 1 here. 3 multiplied by minus 1 is minus 3 plus 1. 1 minus 3 is minus 2. So limit of function 3x plus 1 as x approaches to minus 1 will be minus 2. So you will get this value. Using the table method which we discussed here, or graph method, or just substituting the value, you should get, using all the three methods, you should get the same value. Let's see another example. Here the function is x square minus 4 divided by x minus 2. We have to discuss the behavior of function when x is closer to 2. So we can, at x is equal to 0, if is fx is undefined. Undefined means whenever uh, the value goes to undefined. Let's see, we will calculate and then you will understand more. Like if you graph, you'll see there is let's see, uh, whenever you have values like this, first you should simplify the function. X square minus 4 can also be written as x minus 2 multiplied by x plus 2. So x minus 2 and x minus 2 gets cancelled. The only value remains is x plus 2. So you should simply try to simplify before calculating the value, or you can calculate the value without simplifying that, but it will take too much time to calculate the fx values for each of the values of x. So in this is a table in which we have decided on the values which are closer to 2 but not 2. So whenever you choose a value which is, you should choose on both sides a greater than 2 and less than 2 on, so that you can get the idea. So here whenever you put these values, x values in this function, or in the function x plus 2, because we simplified it by x square minus 4 can also be written as x plus 2 multiplied by x minus 2. Let me open a notepad to make you understand more. Yes. So here x square minus 4 can also be written as x minus 2 multiplied by x plus 2. So here in this one, sorry, this is the different tutorial. Here in this one, um, and we just saw that x square minus 4 can also be written as x minus 2 multiplied by x plus 2. So x minus 2 in the denominator and x minus 2 in the numerator gets cancelled, and the remaining value is x plus 2. So the actual function is x plus 2. Now for each values of the x, we will calculate the fx value by just adding 2 to the value of x, because we just said that fx is equal to x plus 2. So you will get these values, and here you see that as the x approaches to 2, the fx approaches to 4, 3.999 and then 4.001. That means as x approaches to 2, the fx approaches to 4. So using the table method, we get the answer as 4. Using substituting the method, like substituting 2 in place of x plus 2, we'll also get 4. So fx is equal to 4. Therefore, when x is closer and closer to 2, fx is closer to 4. So here is the limit. X square minus 4, x minus 2 is equal to 4. So I hope you got some idea on how to calculate the limit using the table or by substituting values. Let's see this example, x minus 2 divided by mod of x minus 2. Mod it means absolute value. Whenever this value, after calculating this value, when it comes out of the mod, it becomes positive. So mod always defines absolute value of the equation inside the mod. So let's see the behavior and see if the limit exists. So when x, we have to calculate when x is closer to 2. So here we see that when x is closer to 2, that means if we substitute the value 2 in place of x, 2 minus 2 is 0. So whenever denominator has a 0 value, that means the function is not defined. Using table method also, we see that we took values less than 2 and greater than 2, and when we substitute these values, we see that the value comes as minus 1 here, and for 2.001 it's 1. So it's approaching nowhere. That means it's approaching, we cannot say if it is approaching 0 or wherever, because it's minus 1 and 1 has lots of values in between. So we can say that it's not defined. Here also, if we try to simplify this equation, x minus 2, when it comes out of mod, it has both positive and negative values, because as of now we don't know what is the actual value. So first we will take minus of x minus 2, which will cancel and make it minus 1, and then if we take positive of x minus 2 in the denominator, then both will get cancelled, and then we'll get 1, positive 1 here. So we have minus 1 and 1 value. So in case of whenever the it's get closer to 2, with the limit is not defined. The function is not defined when x is equal to 2. So here by plotting the graph, we know that its value is less than whenever the x approaches to 2, the y value is either minus 1 or 1. So at 2 it is not defined. That's why we have this open dot here, open circle, not a dot. The limit does not exist because the limit on the left and the limit on the right are not the same. If yeah, and limit of fx is equal to minus 1 represents the limit on the left of 2x when x approaches to 2 but not to 2. Minus represents x approaches to 2 but not including 2. Similarly, when limit fx is equal to 1 represents the limit on the right of 2. That means whenever you want to represent right of 2 but not 2, then you have to say x approaches to 2 plus, as shown. We write and call k the limit from the left or left hand limit if fx is close to k wherever x is close to c but to the left of c on the real number line. And we write and call L the limit of from the right or right hand limit if fx is close to L whenever x is close to c but to the right of c on the number line. So here in the left represents 2 minus x c minus or any constant value minus, and here right represents c plus on the but not including c. In order for the limit to exist, the limit from the left and the limit from the right must exist and be equal. So let's discuss the behavior of fx for x near to 0. So whenever x is near to 0, x is near to 0, fx is also 0. So when x approaches to 0 minus or x approaches to 0 plus, fx equal to 0. And when x approaches 0, again it is 0, f0 is 0. Now let's see if x goes near 1. So where is 1? Here. Since here is the circle but not dot, that means the 1 is not included. So 1, as x approaches 1, the limit is the y also approaches 1, because when you draw a straight line to the y-axis, this is 1 and this is 2. So as x approaches 1 in this graph, y also approaches 1. So but not approaches 1 here. In case of x approaches 1 plus, that is greater than 1. Here it's less than 1, but not 1. 1 minus means less than 1 but not 1. So as x approaches near to 1, that is 1 minus, not 1, y will approach to, or function will approach to 1. Here the next example is, let limit of fx as x approaches to 1 plus. 1 plus means greater than 1. So as x goes this side, which one is the answer? This, we will take this graph as the answer, which is not 1 but greater than 1. So as it goes away from 1, the limit is 2, because it starts from 2. So y value is 2. For fx is equal to, as x approaches to 1, there is no plus or minus sign. That means it's asking at exact value at 1. At 1, we see that there is no dot. There is a circle. That means the limit does not exist at both the cases. On 1, there is no limit. So we can say that f1 is not defined. Let's discuss the behavior of fx as x is near 3. So where is 3? 1, 2, and this is 3. Let's say y here. So here it is defined. Why? Because there is a circle here. That means in this graph, f, if x is less than 3, it is defined. X is greater than 3, it is defined. If x is less than 3 on this side, and it approaches 3. So when x is less than 3, it is answer is 3. If x is greater than 3, it is again approaching to answer is 3. Only at 3 defined. So this is the, let f and g be two functions. Limit of x approaches to c, fx is equal, and limit of x approaches to c, gx is equal to m. Excuse me. Where L and M are real numbers, both limits exist. Then limit of function k as x approaches c for any constant k is k. This is the property. If there is a constant function here, constant for any if there is a constant, no variable here, as x approaches to c, the answer will always be the constant. If there is a variable which says x, as x approaches to c, then this constant value will replace c and the answer will be c. Whenever there is a limit of fx, first function plus second function, which is gx, which signify this one, as x approaches to some constant c, then we can write it again as limit of fx as x approaches c plus limit of gx as x approaches c. Then the answer will be adding both the limits individually, L plus M. Same in the case of minus. We just separate them as a different limit functions, and then we just put the value and minus it. In case of multiplication, it's a little different. When it says limit of kf, where k is a constant, we take the constant out and then calculate the limit of that particular function and then multiply that constant with the value of the limit. So here k multiplied by L is the answer for any constant k. K is the constant here, remember. In case of two function multiplication, we have to separately calculate the limit of two functions and then multiply them. In case of division, we have to separately calculate the limit of both functions and divide them. And where m should, the lower function limit should not be defined, but that is m should not be equal to 0 for this function to be defined. In case of square root or any root of the function and then calculated limit, just calculate the limit and then take the root of that value where L is greater than 0 for n even. Limits of polynomial and rational function. is also for limit of fx as x approaches to c should be fc for f for any polynomial function, and for limit r x or x approaches to c will be rc, r for any rational function with non-zero denominator at x equal to c. So these are quite easy, you don't need to remember, it is simple, you can just calculate the normal limit and apply the rules of multiplication division. Let's see another example. X square plus 5x is the function, and we have to calculate as a limit of this function as x approaches to minus 2. So what, as we have learned in the past, we can separate these two in two different limit function. Limit of x square as x approaches to minus 2 and limit of 5x as x approaches to minus 2. Now putting the values, here we can again separate it using the property 4 and 3 here, and separate the constant, calculate the limit, separate the two multiplication, and then calculate the limit separately, then just put the values and then calculate like normal math function. So here you can calculate this is very easy. Similarly, for the root, as we discussed before, first we calculate the limit of the function inside the root, and then whatever value get, calculate the root of that value, you will get the answer. Similarly, for these, calculate the limit separately for numerator and denominator. Denominator should not be equal to 0, and then we calculate the separately calculate the limit by putting the values of the variable, and you will get the answer. In example 7, let's see. It says function x is equal to 2x plus 3 minus x plus 12. If x is, for first one, if x is less than 5, for the second function, if x is greater than 5. So let's see. If says if x is less than 5, not including 5, that means 5 minus. So limit of fx x approaches to 5 minus. We'll put the value in the 2x plus 3. By putting the value 5, we get 13. Again, putting value 5 in the second function as x approaches to 5 plus is the value 7. So we have two values here, 13 and 7. So at 5 the limit does not exist because the left hand and the right hand limits are not equal. If whenever the left hand and right hand limits are not equal, that means this function and this function do not give the same value. That means at this particular value, that is at 5, the function is not defined. That's why it says if x is less than 5 but not 5, not equal to 5. So this is the way you can find out if fx is defined for a particular point or not. Indeterminate form. If limit of fx as x approaches to c equal to 0 and limit of gx as x approaches to c, then fx by gx is indeterminate, or more specifically a 0 by 0 is indeterminate form. Then limit of a quotient. If limit of fx as x approaches to c is equal to L, L is not equal to 0, and limit of gx is equal to 0 as x approaches to c, then limit of fx divided by gx does not exist. Whenever there is a 0 in the denominator, it does not exist, it's not defined. So here is the example of to analyze indeterminate form. As x approaches to 1, if you put 1 here, then the value of x square minus 1 will be 0. So clearly this is not defined because the denominator is 0. So for determining if it is indeterminate form, you just put the constant value in the variable under the denominator, and you will see that whether it is defined or not. Whenever you get 0, then it is not defined or indeterminate form. Here also, if you put 1 x square minus 1, that is 1 minus 1 is 0, so not defined. Here also 1 minus 1 is 0, 0 square is 0, so it's not defined. So here again I have calculated it. X square can also, x square minus 1 can also be written as x minus 1. uh, so x minus 1 gets cancelled, so the value remains is x plus 1. So limit of x as x approaches to 1 is 1, x plus 1 is equal to 1 by 2. In this case, limit of x minus 1 whole square, x square minus 1. So simplifying by like this, x minus 1 whole square can be written as x minus 1 multiplied by x minus 1 divided, and denominator is x minus 1 plus plus 1. So x minus 1 gets cancelled. So by putting the value, it's x minus 1 divided by x plus 1 is 0 by 2, which is 0. So here I said it wrong. First you need to simplify to see if it is undeterminate form or not. By just putting the value, you see that all these three seems undefined. Like this is undefined and this is undefined. All three seems undefined. So first you need to uh, uh, break the factor all the equations and then see whether it is defined or not. Not just by putting the values. So here we have to define, first we have to calculate and see if it is defined or not by factoring it, and after making it to the simplest function, then putting values to see if it is defined or not. So in this case, after factoring and cancelling the equal functions, we found that these two are defined, and in this case again simplifying, x square minus 1 is x minus 1 multiplied by x plus 1, and x minus 1 whole square is x minus 1 multiplied by x minus 1. Then these two gets cancelled. The final value is x plus 1 divided by x minus 1. This is clearly denominator is 0, so this particular value is not defined. So the rule is, when you find the limits of the above problem, you must factor first and then simplify before you substitute the number of x. So remember this, first you must factor and simplify before you substitute. So here is the indeterminate form. Find the following limit for the following function. Fx is equal to 7 minus 2x. Limit of h is equal to 0. F4 plus h minus f4 divided by h. So let's see how we can calculate these. Fx is equal to 7 minus 2x. F4 plus h is 7. When 4 plus h means we have to substitute the x value with 4 plus h. So f of 4 plus h, that means we have to substitute x in place of 4 plus h. So 7 minus 2 multiplied by 4 plus h, because there was x here, we substitute x with this value because it is asking us to calculate function of 4 plus h. So after simplifying, you get the value 7 minus 8 minus 2h, that is, and then we calculate for f4, which we get 7 minus 8. Now calculating this, whatever it is asking, we have to calculate the limit of this particular function. So by putting the value of f4 plus h, which we got this value 7 minus 8 minus 2h, minus f of 4, which is 7 minus 8, which we got, divided by h. So as h approaches to 0, so then we simplified this is minus 2. We know that we can cancel 7 minus 8 minus of minus 7 minus 8. These two get cancelled. Minus 2h is the remaining, minus 2h by h, and both the h get cancelled, so the value is minus 2, because limit of a constant is always the value which it is denoting. So this is how we calculate. Similarly, for the next function, we have been given fx is equal to x mod of x minus 1, and we have to substitute the value 1 plus h. We have to what we have to calculate, we have to calculate this. So separately you substitute 1 plus h in place of x and calculate the value of function. Then you substitute 1 in place of x and calculate the value of function, and then finally put the values, the respective values, to calculate the value of this particular limit. So here is the solution. For we calculate 1 plus h and we get the mod of h. F1 is 0. So 1 minus 1 is 0. So then we're putting the values, limit of mod of h by h, which also gives you minus 1, because the limit on the left hand and on the right hand are not same, therefore the limit does not exist. Because h approaches to 0, whenever there is a mod, that is absolute value, you have to calculate 0 minus and 0 plus. So for 0 minus it is minus 1, 0 plus it is 1, because whenever you break the mod and take out the you have to consider both minus and plus values. Since both the values are different, we know that it is not defined. Similarly, for the next example, you have to calculate the value of this square root of 3 plus h minus 3 divided by h. So you calculate the limits, calculate the function separately, then put the values, then calculate, and finally you get this value. You can do it by your own. You just need to substitute and then calculate the limit value. So guys, I hope you got some idea on the introduction to limit and how to calculate the values. So practice makes a man perfect, or woman perfect, or a girl perfect, or a boy perfect. So practice, 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 and you will get to understand limits. It's very easy and fun. So come back to my channel and subscribe to my channel for more videos on limits and other math tutorials. Thank you very much for watching. See you soon for next chapter on limit.